Today we're going to be working on just kind of completing the remaining few examples of this worksheet. Again, this is not one of my worksheets that I've created. Mine will say my name at the top, which is Morrissey. So we'll just kind of work on these after watching our video. That is, if you need just some extra support. So see if you can pause the video and try these out. I'm going to show the answer key here in a moment. Here is your answer key. So keep in mind as a refresher, right? We could use your swoop method, which I've shown down here, right? Which when you swoop, you start on your base, you come up and around your value, and then you land on your exponent. One thing about the swoop method is that it's not really natural to write the word ln because you go from an exponential into a logarithm, so you must write a logarithm of some form. For me, my other preferred method is to actually write the word ln or logarithm when it goes to converting. So for us, keep in mind the idea or the relationship that e and ln share is that if they have the exact same base, in our case, ln has a base of e, they will end up canceling each other out. That is because very much like x squared, when we square root it, it's just x. Or in the reverse, if we have the square root of x, and we go to square it, again, it's just x. That is because you take one thing and you are going to undo the process that the other one has done. So that is kind of our idea here. So we always want to make sure that your exponential term is all alone into one side. So if it has any sort of coefficient, we definitely want to divide that out. If it has any sort of constant, we want to make sure that that one gets moved first because it's easier to add and subtract things over than it is to multiply and divide. So let's go ahead and subtract this 9 over to the other side. And then we can go ahead and divide by your coefficient. So we have e to the x is equal to 1. Now, actually, this one is an important rule. So in doing so, right, what this one, you might actually want to do the swoop method. Or actually logically think it out. What does x have to be in order for this whole thing to be equal to 1? Right? X to the what power is equal to 1? Well, that has to mean that it's equal to 0. And if we were to plug that in, right, e to the 0, that is equal to 1. So 9 minus 2 times 1 is equal to 7. So this is equal to 7 is equal to 7. So you can always double check your answer if you're not quite sure what it is. Now let's go ahead and try number 8 here. Again, you have a coefficient here. So let's go ahead and divide that out. So you have e to the negative 2x is equal to 35 over 100. I like fractions and I'm going to keep it as such. Now when we look at this, right, we want to write your natural log of both sides. And what that allows us to do is this cancels and drops your negative 2. So we have ln of 35 over 100. And then we can go ahead and solve for x. So divide both sides by negative 2. So x is equal to ln of 35 over 100 over negative 2. And I'm not sure if your answer key has reduced it much further or if they've taken an approximate solution. Yeah, so they reduced it just a little bit between what they have in common with 35 and 100. So 35, they both have a 5 in it, leaving behind a 7 and a 20. So that's all they did here. I figured they would. Let's see what else we have left over here. So for number 15, we have a few different methods that we can use. One thing, I'll show you both, but one method is to actually go ahead and show the power of your radical, and then take your properties of logarithms, which we're going to put that 1/2 right in front. Ln of x plus 2 is equal to 1. And this is really dividing by 2, so the opposite of division is multiplication. So we have ln of x plus 2 is equal to 2. Now to get rid of your logarithm, we can write everything to the base of e. That'll allow us to cancel that ln and the x plus 2 to drop. So we have e squared over here and then subtract by 2. So x is really equal to e squared minus 2. So that's one method. Another method is as long as your natural log is all alone to one side, we can go ahead and take e to both sides. We can go ahead and take the e of both sides. E because you have your base here of e, so that'll cancel. We're left with x plus 2 under that square root, e to the first power. Now we can go ahead and undo your square, which we get to square everything here. X plus 2 is equal to e squared, right? 1 times 2 is 2. And then go ahead and solve by subtracting your 2. So you'll notice that you get the same thing in the end. It's just a matter of preference on how you approach these and solve. We'll do one more, and again, I'll show you those two different methods here. Again, as long as ln is alone on one side, we might wish to do this first. So bring that 2 out front. Ln of x minus 2 is equal to 12. Go ahead and divide everything by 2 here. Ln of x minus 2 is equal to 6. Ln is alone, so we can take everything to the e. X minus 2 is equal to e to the 6. And then x is equal to e to the 6 minus 2. Or sorry, plus 2. So that's one way. The other way is, as we talked about before, as long as natural log is all alone to one side, we can go ahead and take the e of both sides. Take e and e, that'll cancel and drop. X minus 2 squared is equal to e to the 12th. You'll notice that we now have to undo your square, so we can square root both. X minus 2. And we normally put your plus or minus sign here, but keep in mind what we know about ln and your negative values. We want to make sure that x is equal to a positive value. So now we can say e to the 12, and keep in mind what we know about radicals. Radicals has the exponent of 1/2. So we can say this is really divided by 2. So we have x minus 2 is equal to e to the 6, and then go ahead and add the 2 to the other side. And there you have it. And there are a few more here if you needed. These were a little bit more basic. They also use the swoop method if you'd like, but I'm going to show you the answer key. That way you can work some of these on your own.